All right, I have some goals this semester. A lot of you have some goals. Make it through, get good grades. So I'm going to teach the fundamental concepts of chemistry. That's why you're here. That's why you're all excited, right? And hopefully I'm going to make chemistry fun and interesting. How could chemistry not be interesting? All right, how many of you are afraid? Good, everybody's got a good, healthy sense of accomplishment. You know you can do it, right? How many of you are too shy or embarrassed to be honest? I hope to ease your fears. I hope to build some of your skills. Here's the worst part. I got to rank my students. That's why I give the quizzes every Friday. But I give the quizzes every Friday for two reasons. Lights a fire under you to make you study. It's good. It's part of my job. The main thing is you need feedback, whether you're getting the concepts, and I need feedback. Sometimes I do the quiz and I say, man, I'm gonna have to go over this concept. I need to cover this more. And so that's the stick part. There's like two, there is a carrot part. You've heard of a stick and carrot, right? Especially egg people maybe. The carrot is when you're like, oh, why do I study for the exam? I say, pull out your quizzes. I'm a lazy person. I'm gonna just take questions off the quiz, at least 90% or so. So what is chemistry? It says here it's the science concerned with the composition of substances and the changes that substances undergo. Science of change. We might define substances a little better and say matter. What is matter? I have an old chemistry instructor who said matter is anything that takes up space and has mass. Anything that has mass and occupies space. And then he challenged us to think of something. And maybe the bright person said, well, I'm going to go over there and I'm going to turn off the light. And I'm going to fill the room with darkness. I turn it back on, I'm going to fill it with light. Eventually we'll get to a chapter where we find out that light can have momentum, can behave like a piece of matter. I mean, only things that have mass have momentum. And light is electromagnetic radiation, and there's ways that matter and electromagnetic radiation are related to each other and interact. And also when we study chemistry, we're studying atoms, compounds, molecules, things you can't see with the visible eye, and how matter might interact with electromagnetic radiation is one of the tools we use to study matter. We also say matter has measurable characteristics: weight, volume, temperature, and density. When I think about chemistry, I can say it's all about electrons. We'll learn that a chemical bond, there's a couple types. One type is when two atoms share electrons. We call that covalent. Another type might be an ionic bond where one atom has hogged all the electrons, the other doesn't have it, and we say it's two different charges and it's electrostatic attraction holding those things together. You heard that opposites attract, right? And we'll learn that the periodic table is kind of laid out with electrons filling orbitals. And you'll see a 2-column part of the periodic table, a 6-column, a 10-column, and all those will have some meaning. Chemistry is called the central science, and we don't have a whole lot of chemistry majors anymore, turning into a dying breed. But we teach a lot of chemistry classes for other majors, so we sometimes say we do service. Medicine, you need to know a lot about chemistry. Biology, you need to know a lot about chemistry. I was told that physics explains chemistry, and then my math major friends said, well, math explains everything. And I'm like, oh, let me sit at your feet. And geology, geochemistry. I like to think about geochemistry with those reactions that take a long time, like stalagmites and stalactites cave, perhaps. So I see chemistry everywhere I go. Do you? Honestly, see it everywhere I go. Sometimes I'll say I was walking my dog and this happened. All right, let me get fired up here. Got my laser pointer going. All right, which items are related? Let me come over here. Where are the models? Left or right side? Yeah, these are models. You thought I meant like Christy Brinkley. Now you know how old I am. Who's that? I don't know any modern day models. Yeah, so these are models. We can't see atoms, and so sometimes we use models. So there's a couple models here, and there's what else do we got going on here? So let me give you a hint. A black sphere represents carbon. A red sphere represents oxygen. White spheres represent hydrogen. So What's with this old thing? This old picture. This was before Amazon. Guys delivering a package. I'm glad. Granny has sent me some Crane's black lead. She has used it for almost 60 years, and we always call it the real servant's friend. Black lead. What do you think they're talking about? Lead. There's an element up on the thing called PB, but that's not it. That's a different type of lead. That's the type of lead you fill somebody full of when you're in a Western, right? Pencil lead. Absolutely. All right, so this pencil lead and this model are related. All right, let's think about that. So the lead in a pencil is called graphite, and black is our universal symbol for carbon. But these are all carbon atoms, and graphite forms these sheets, and that makes graphite kind of slippery. If you're a locksmith, you might have a bottle of powdered graphite used to lubricate things. Of course, my goal would press some graphite real hard together and form a diamond. This almost looks like a diamond. It's all carbon. I'm really glad I got the presenter view to work, and my laser pointer still works. All right, so he's selling pencils, and there's some lead and lead. All right, what calling people? Mercedes. All right. Anything you want to link up to this picture? The ice cubes are H2O. Very good. Right here, there is an H2O. And there must be some other molecule there. And these look like silver spheres. Silver is Ag, but this isn't. Those must be gas. What do you suppose the gas is? Carbon dioxide. So that must be this thing, right? CO2, and here is H2O. For some reason we do the formula in little different order. What makes soda pop fizz? Yeah, carbonation. Carbon dioxide likes to be a gas, and if you read the label, it will say carbonated water, or it will be say carbonic acid, and your pop's under pressure, and when you screw off the cap, pressure goes down, and carbon dioxide wants to come out of solution, starts to fizz. Now look at this model. There's a bunch of other stuff still in here. What do you suppose that is? What? Flavoring. Well, here's a big flavoring molecule right here. We're gonna get to carbon dioxide. CO2 is a gas that causes fizzing. Now the first ingredient on the soda is water by mass. Now it's real healthy to drink water. That's why I brought some in. That, and I got something else planned. I'm gonna run out of time. Just having so much fun. Time flies. I should bore things down a little bit. Soda pop's second ingredient is sugar, which is a simple carbohydrate. Carbohydrate means carbon and these OHs. Kind of like if you stay hydrated, you drink lots of water, and I see an O and an H. So I see part of water here, half, 2/3 of water. I see an HO, 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 carbons. So there's the carbohydrate. And possibly that can make soda pop not too healthy to drink. Now here's the molecule of the day. Nitrogen is blue, the carbons are black, and here's a structure of it. Here's another structure of it. And I kind of messed up my slide, Fanta orange, 7-Up, Sprite. Who has a Sprite habit? Who says Sprite's my brand? When I was a kid, maybe it was Michael Jackson, he used to advertise Pepsi. And I'd be like, oh, I'm a Pepsi drinker. Soda pop contains caffeine. Oh man, you can hardly see this, I'm sorry. There it is, shows up better on the computer screen. They put that in there so you keep buying it. You wake up and you're like, oh yeah, I need my Coke. So graphite, soda pop, what the heck is this? DNA, that's right. Let me jump ahead. DNA is in living organisms. Desoxynucleic acid, I believe, is the D part. And so here there's these phosphates and a type of sugar and these base pairs. Fortunately, I'm not going to test you over any of that. That's biochemistry. The point is, it's there. Chemistry makes things important. So in a human body, we're mostly water. Notice oxygen's pretty high. Oxygen's the most abundant element on the surface of the earth. There's a little factoid for you. And 2/3 of the earth is covered in H2O. And we might get to dirt here in a little bit. If we bought this all as fertilizer, it wouldn't be a whole lot. All right, so here's the great part of the lecture. How many of you know what an agricultural revolution is? The Greeks had one. They figured out you know, how to plant a field and plow it with maybe a beast of burden. And they came up with irrigation. Yeah, so they got good at it, and they got so good at it, they didn't have to spend all their time hunting and gathering. So they had a lot of food around, so once they had a lot of food around, what'd they have time to do? Toga parties, yeah, wear a toga. Now I don't own a toga, but I own a lab coat. Oh, I'm so glad I don't have to go out and hunt and gather some food today. I'm gonna think about life, I'm gonna philosophize. Well look, here's a piece of wood. How'd this piece of wood come to be? Came from a tree. Where'd the tree come from? The tree grew out of the earth. Of course, to make the tree grow, it required something else. Needed a little bit of water. Sorry, this room's so small. I could have switched with the other room, but I really like the linoleum because of chemicals. All right, so the Greeks, you know, they saw stuff came out of the ground, life, like trees. And then they noticed that somehow I'm thinking about LA. Poor people. And then the Greeks, they sat there and they thought about the tree burning. That's why I got linoleum. And I wanted to hold a beaker of ice cubes up here and ask somebody over there to hold a beaker of ice cubes. My toga's coming off. All right, so the Greeks noticed that when you burn something, they noticed the smoke go up and go away. And what did they think it turned into? Yeah, into air. So the Greeks, now what I got here is what? Ashes. Boy, that wasn't planned. I about made perfect dust because the carbon and the glass, we'll get to more of that later. They thought there was just these 4 elements. Is that true? No, you're looking at a table over there and we got 92 of them that are normal, and you know, man, we get up to 118, but a lot of those are weird and nobody has a bottle of it. But what is air? Oxygen is air. That's what keeps us alive. And it's primarily nitrogen. So N2, 2 nitrogen atoms stuck together, and some CO2. All the carbon in this tree turned to CO2. We're going to learn about combustion reactions on Friday. Carbon in the tree turned into CO2, and when you drink some pop, you eat carbohydrates, and your body burns carbohydrates because your lungs breathe in oxygen. You're breathing out CO2 and H2. On a cold day, you can see the water. I gotta speed up. Whenever people start grabbing their stuff, I'm like, come on. Speaking of maybe LA, well, we've all been to Denver, right? Or you get to Cheyenne, what do you see over the horizon? You see this brown cloud. All right, these are all gases. So air is primarily nitrogen, 80% nitrogen, 20% oxygen. And that's down at sea level. Up here, it's probably less oxygen. And bad pollution day, these things break down with sunlight and sometimes turn into O2. All right, so I just have a minute or two to wrap things up. Luckily, I got my clothes on, and I can just rip off my toga. I'll keep wearing my reef. All right, so how do scientists think? See, these Greeks, I gotta come right down here. They just used reason, and they philosophized, and that was it. And they said, we're smart, this is it. What was missing? The scientific method. Scientists arrive at conclusions using the scientific method. They didn't do any more experiments. Like I talked about holding a cold beaker and condensing some of the water out. You know, air is a big mixture. It's not one element. So we're going to learn the difference between compounds and elements. Compounds you can break down further. An element you can't break down any further chemically. Questions. Those Greeks made observations, and then they came up with kind of a reason and said that's fact. What they didn't do is they didn't test any of their ideas. So on Friday we'll test an idea. We'll make an observation and then we'll do a test. Try and get everything finely tuned and oiled. Well, have a good rest of your day.